This is a list of companies with some basic information. And this is that same list after using AI to automatically find and summarize some recent news articles about each company. So the basic idea here is that as a company, you'll have some information about your clients coming from your CRM, your HubSpot, your Salesforce. So what if you could enrich that data by adding context from external source of information, like in this case, searching the web for recent news, recent publications by the company themselves or other people writing stuff about the company. And of course, that's just the tip of the iceberg of what's possible with this kind of approach using language models. If you're working with startups, you could be finding information about recent funding they raised. If you do staffing or recruiting, you could find recent job postings or hirings that a company has made. And so this kind of use of external data, where the information is available on the internet, but isn't freely accessible in a standard format, like from an API. This is something where language models now open up a lot of new possibilities, because with traditional scraping, you always kind of need to know what you're looking for. You need to know the structure of the website that you are scraping data from. And if you're scraping data from 10 different sites, you are basically going to need 10 different sets of rules. But now with LLMs, because you can intelligently parse the results you get from any website, it really opens up a lot more flexibility. And from a data engineering point of view, you can now start to think about integrating this kind of logic into your data pipelines, where you use data from your own systems and maybe some APIs, to now also enriching that data with some external, more free-form sources that previously would have been very difficult to get. So I'm going to show you now how that looks like in the code using Python and the LangChain library with OpenAI's models running on Azure. So looking at our code here, there's basically 4 steps that we are doing. We are looping through each company in our list, in our JSON file. And then the first thing we want to do for each company is find the URL to their newsroom webpage. These are all medium to large sized companies that we are working with here. So they are almost guaranteed, companies like this, to have a dedicated webpage where they post all the news articles, press releases, blog posts, etc. So that's the URL we want to find. And after we find that URL, the next thing we want to do is find all the links on that web page that potentially lead to some articles that are interesting to us. And we'll also narrow down that large list of every single link that you can find on a web page to just contain a couple of most interesting looking articles. And we'll use AI to do that curation of the list. And then finally, once we have this smaller list of article links, then we can just scrape each of those and create summaries from each article, again using AI. And then we can just add all those summaries into our client object. So let's look at each of these functions in a bit more detail. Like I said, here we are looping through each of our clients and then get the name. And we use that name to call the find newsroom function, which is a very simple function. There's no AI involved here yet whatsoever. We are simply running a basic web search using the Serper API and a search query like this: company name, company newsroom. And we get the top result, which is very likely to contain the result we want. We return that link, and then we can use that link to call the next function. And this function is where things get more interesting. In the beginning, we just, again, do some pretty basic stuff. We just get all the HTML content off the website by using a web request. And then we parse that content using the beautiful soup library in Python, which is used for this kind of stuff. And namely, we want to just get all the link objects in the HTML. And we'll also filter that list of all the links even further by using some conditions here, which allow us to get rid of some generic links that have nothing to do with the articles that we actually care about. But we are still going to have a very large list of links here, and it's going to contain not only older articles that are not so relevant for this search, but also things like links to the company's social media profiles, most likely, depending on the website structure. So here we are going to pass the list to our language model, and we are going to ask the model to select only up to 3 links from that whole list that seem the most likely to lead to an interesting news article about the company. We'll give some additional instructions about ignoring generic links, and then we'll specify the output format a simple comma separated list of the links. And if for whatever reason the language model fails to find links, then it will simply return none, and this we can use to then skip that company and move on to the next one. And then for the actual language model interaction, we are using a LangChain, which is a concept in the LangChain library. I won't cover it in detail in this video, but there's plenty of information available in other places. LangChain has become one of the most, if not the most used library for creating applications in this space. They just have a lot of useful components that just make it a lot faster to get started building this stuff. So highly recommend you check them out. LangChain is the library. And the output is going to be a string, and then we'll split that string to get a Python list of the URLs, which we can pass to the next function. So we'll pass that list to the scrape articles function, which is simply going to loop through each item in the list. And again, we are just starting with a simple web scrape of the website contents for each article. And this time, to parse that HTML, we aren't using beautiful soup, but rather we are using a different library, HTML2text. And the reason is that it offers us these two useful features, which is to ignore links and ignore images, so that we only get the text back, which is the only thing we care about in this context. Because just like in the previous function where we already trimmed down the initial list of links before passing it onto the language model, again, if we have an easy way to trim down the amount of content that we give to the AI, it's going to be a good idea to do so, because as you probably know, these models are built by the number of tokens, essentially characters, that you use. And so the more you can bring that number down, the more efficient it's going to be to run these applications in reality, in production. It's going to be faster and it's going to be a lot cheaper as well. So we get back the text for each article, and then we simply take that text content and pass it to our last function, which is summarize, which is going to create a summary of that article for us using AI. And there's a few new concepts here, again from LangChain. This part essentially allows us to use some pre-built tools to create what are called chunks of the full article text, because sometimes articles can be quite lengthy. So in order not to run into the token limitations of the models, we often want to split that text into pieces, and then we can work with those chunks instead of the full article. And in this case, we're using a chunk size of 6,000, which means that we get chunks of at most 6,000 characters, and however many chunks of that size come out of the article. And then we can work with that list of chunks by using another different type of chain this time, which is a summarization chain, which is exactly designed to take in a list of chunks and then create a summary of the entire thing. And the output is simply going to be the summary. We return that to the previous scraping function, and then for each company, every time this runs, we create a list that contains the URL to each full-length article, followed by the summary. And we have 3 of those more or less per company in a list, and then we return that to the main function, add that list as part of the client object, and finally, when we have finished this process for each company, we'll just write all those new objects into a new file. So what I'm gonna do now is I'm gonna delete the file I've created earlier with the news, and then we're gonna run the script again just for you guys to see. And this is probably gonna take around 2 or 3 minutes, so I'm just gonna speed it up from here. And there we go, it's successfully ran, and we have the news items here. And the reason why I wanted to run it here is to show you guys this, which is my Azure OpenAI instance. And here we can look at among other things, we can look at the consumption of the models. And if we select the last 30 minutes, and we select the processed inference tokens, which is the total sum of all tokens consumed by the model, both for the prompts and also for the completions, we can see that it comes up to around 55,000 total for that run. And in terms of pricing, that might sound like a lot, but if you look at the pricing for Azure OpenAI, it's actually for GPT 3.5. This is the price per 1,000 tokens, and it's a little higher for the completions. But all in all, this means that for 100,000 tokens consumed by the models on Azure OpenAI, you will pay about 30 to 40 cents, US cents. And so what that means is that our 55,000 here for summarizing those 15 articles, as well as processing the links, selecting the top 3 links for each company, this comes down to about 15 cents. So the consumption is definitely pretty reasonable, even for a use case like this that does use a lot of data. Of course, if you scale that up to thousands of articles, it can become significant. And that's again why it's important to be mindful and asking yourself if there are some ways you can minimize the amount of tokens that you send to the model. But overall, this isn't too bad. So that's it for this video. I hope you got some useful ideas out of it that you can then play around with yourself, and I'll see you on the next one.